Good day. In this lecture video, we will be discussing the bisection method. The bisection method is a bracketing method and is used to solve equation in the form f of x is equals to 0. As discussed, since this is a bracketing method, an interval is identified from a to b, wherein the true solution is within this interval. As you can see in this image, we have an interval from A to B, and then we make sure that the solution is within this interval. It is also important to note that in this method, it is required that the f of x should be continuous in this interval for this method to have a solution. That means that this function should be continuous at that interval, okay, so that the bisection method would work. Additionally, as shown in this figure, it is expected that the function of the endpoints of the interval f of a and f of b has opposite signs. That is, one should be positive and the other one should be negative. It could be that f of a is negative and f of b is positive and vice versa. Just either one of these function of a or b. Thus, if we multiply f of a and f of b, since they have different uh, signs, then they should be less than 0. Since f of a and f of b has opposite signs, one is always negative. So that is why if we multiply f of a times f of b, the solution should be negative. Okay, so how does the bisection method works? And how does the bisection method find the root or an equation's true solution? So we have this following step. Well, first, the initial interval a and b must be identified when it should bound the true solution. So you should identify an interval from a to b, and that within this interval you must make sure that the true solution exists. So in finding the a and b, we should take note that if we take f of a and f of b, both of them, the solution should have a negative value since one should be negative. Okay. Okay. So now the initial interval that we find or that we determine, we call that maybe a1 and b1, could be determined by creating a graph of the f of x as shown in the figure. So the initial interval a of b could be identified by just what I have explained by finding f of a and f of b and multiplying them. If they have negative solution, then that is a proper f of a and f of b. Another method is to plot them in the graph. Okay, so just like this. Okay, so we created a graph of f of x. So if you have a graphing calculator or any other software that could graph function, we could easily plot f of x or find the graph of f of x and see what is the appropriate value for a and b. Okay, and observing where the graph crosses the x-intercept. So if we create a graph, just like what I've said, and we determined a value of a and b, uh, we make sure that the intersection of that graph to the x-axis, this should be the true solution. We make sure that within this interval, we find the true solution. Okay, another method is by finding an x value, say m here, that could cause f of m to either be negative or positive. So this method is what I've just explained, that is just finding a value of a and b that when their functions are multiplied, will result in a negative value. Okay, so let's proceed to the next step. Okay, the midpoint, say x sub 1, x sub n s 1. So this is the initial midpoint that we find. So the midpoint is just the halfway value within a, from a to b. Okay, so it's considered the numerical solution. So that midpoint is now considered as our initial solution, or our first estimation of a true solution. We will then check if this midpoint here is a good approximation of the solution. So if it is not, which is the case of our example, as you can see here, this is the true solution, but our midpoint is somewhere here. So which is kind of far away from the true solution. So we say that this first estimation should have a great error, or is not an appropriate approximation true solution, because it is quite far away from the true solution. Okay, so but basically this is how we find, or we approximate the true solution. We just solve for the midpoint of A and B. Okay, so what will we do next to find the next approximation? Okay, so what we do next is we will determine if a true solution is between A to x sub ns1, or or in x sub ns1 to b. To do so, we will check these following conditions. So this is the conditions that I'm talking about. Okay, so basically what we do is we check. So look at this one here. So we found our x and s1. What we do is to check whether the true solution is within this interval from a to x and s1, or from x and s1 to b. Okay, so to determine which of these two candidates should be our next interval, we test these conditions. Okay, so if f of a, this one, times f of x sub ns1 is less than 0, that means that the true solution is between this one. Okay, but if it is not, then the true solution is within this one, within this interval here. Okay, so now why do we test using this? Again, we determined a and b such that f of a times f of b should be less than 0. Okay, this is our initial interval. To find the next interval, we find again, no, from the x, using the our initial x sub n s1, or our initial approximation. Gamito na to ni siya. Kung kani f of a of x sub ns1 is less than 0, sa ato pa na diri a. Kung dili, then na diri a. Okay, so nga na lang yun, dapat na yun nga to ang a ug b is always, kung i-times na to ilang function, dapat less than 0 lang yun siya. So, nahitabo diri a, sa ato ang illustration, makita man nato, from a to x and x sub ns1, wala diha ang true solution. So, kung ato ni siyang isolve using this condition, this here should be false, no? So, that naada, so ang ato ang next nga interval should be x sub ns1 to b. Now, what happens is that kani nga to ang x ns1 muna ni siya tong bago nga a. Okay. And b is still r. b on the next iteration. Okay, so as what I've said, in step 4, we will create a new interval. So, gikan sa katong unsay solution nato, unsay result ani nga condition. Okay? So, kung kinsa man ganitong naa in between ang true solution mo na to atong bagong A and B, atong bagong interval. So, ang hitabo ni ron, just like what I've said, ang atong x sub n is 1 mo na atong bagong A and RB is as is. Since naman diri ang true solution, so diri ata nag kani atong sunod na kani atong sunod na interval. Okay? So, again, buhato na po nato no the same method. Ato na po dayon siyang pangitahan og midpoint, no? Muna man itong bagong A ug B, muna dayon ni atong sunod na approximation, si x sub ns2 diri sa tunga, no? So, kung panahon nato ang ato ang sunod na estimate is very far away from the true solution. So, this is not yet the correct approximation. Ato man ang i-test through error. Katong akong gi-explain sa atong previous nga lecture video. So, kani, kung makita nato since naman diri ang true solution, so ang atong bagong interval should be from A to x sub ns2. So, muna ni siya karon. And then we will find the midpoint again. Tapos kana nga midpoint, ato na po dayon, muna po dayon nato ang estimate. And then, ato lang dayon nang i-repeat na process. Hangtod sa makakuha tag error na gamay or less than 0.001 or depende sa inyong pagkaset.